So the next talk is by John Smith. The title is Experiment on Generating Self-Image for Robot using, cannot pronounce this one, Piezoelectric Network and Transformers by Android Robot Ultra 3. So please.
Thank you. And could you hear me? And
yeah,
yes,
you're watching. Yeah, thank you.
We can see it.
So start. So I'm John Smith. So my presentation title is Experiment on Generating Self-Image for Robot using Piezoelectric Networks and Transformers by Android Robot Ultra 3. So our lab has been conducting research on the self-image of the Android robot Ultra 3. And so this is an experiment of the imitation humans by Android. And these results have been presented in several papers and exhibitions. So this timing, self-image made by generated by using 3D models and potentiometer values to create a potentiometer value. So Ultra 3's body model so far has been generated by giving angle information into a 3D model. So we want to make new model or Mod 3 embodiment. So this is Ultra 3, and so this Android has 43 axes of movable joints, and it has motor command. It's called set axis, and so potentiometer value for each joint. It's get axis, and built-in camera in eyeballs. So the whole body moving by air actuate. It moves flexible by changing the air pressure of each joint actuator. But he can't precise movement by electric motors like Asimo. Yeah. So what we call self-image. So I think self-image is like a map of the embodiment. So if I close my eyes, but I understand where is my hand here. But Ultra 3 moving just motor command. Ultra 3 can't understand where is own hand. So they can't shake hand. So our first system, Ultra 3 always understand which axis moves for how degrees. Maybe like shoulder 30 degree, elbow 90 degree. Okay, my hand is here, like that. But we think self-image do not generate by vision and axis degree. So then we want to make body image from pre-procession. This is not outside world model, just understanding of Android's own body model. And we think that fuzzy self-image looks like encoder-decoder model's low-dimensional internal state. And so we try to creating more human-like self-image. So we installed 48 piezo sensors on Ultra 3's body surface, which we regarded as body surface senses and try to generate a self-image based on the vibration, so on the body. So, uh, 1 to 16 is the right side of body, and 17 to 32 in the right side body, and 33 to 48 number piezo put around the waist and legs. So moving axis and ERP piezo sensor make so relational value moving start and end like that. So blue is so get axis, so potentiometer value, and orange is a PS value. And then we try to use transformer for making self-image. Transformer is different from previously machine learning architecture. The transformer is a learning model built on structure of where to direct attention to given piece of information. So attention eliminates the need for the kind of long-term memory that was necessary for learning in the past, making it easier to parallelize, and the use of attention makes it easier to guess where the model focused its attention and produced its results like that. So in this research, we use two pattern movement set. First, random movement. This movement controlled by white noise. Every joint, different random value and moving, so left side. And second, human design movement. This is a conducting movement for orchestra. So we have tried to enroll robot with orchestra, and that's artwork named Scary Beauty. That is a this timing artworks enrolled moves recording data. So for training in transformer, we input 48 phase value in whole bodies and 20 steps inputs, and infer the last steps value of get axis. So we think it's like a pause at that timing, like that or like that. So pause infer transformer try to infer pause. Then shift one step, and end of timeline. And we try to run ladder movement model and infer the human design movement. Okay. So transformer don't know human design movement value. And this is the result. So attention-based learning by the transformer has been shown to be able to infer the android's movement like that. Yeah, sometimes so transformer make mistake, but sometimes so transformer understand. So like the correct value looks like correct value, and repetitive movement easy or we think. But sometimes so it stop and make a big move. I think it's a bit difficult. And this is a video comparison. So left side is the original conducting move, and right side is a transformer making value into android. So also value is not same. Sometimes so transform making wrong value, but so overall mood is very similar, I feel. And this is attention map in encoder layer. We found some vertical line in merge head attention like this, or sometimes here, or this can be interpreted as an indication that the pattern of vibration during the particular motion has an effect on the infra body state rather than changes in the time duration. And this is different timing, so attention, but so we can find same piezo value getting attention like that, same axis in here, maybe. So we think so infra body movement has a important part of body. Oh, this is summary. So self-image generation has been achieved. So in this approach, we attempted to use the transformers to generate a self-image of the android himself. And transformers attention found important body parts. So part of body, sorry. So for infra, embody movement, so through the piezo sensor. Our model did not perfect running for original data. So we think so model include predictive approach. So but it's abstract like a moving atmosphere or mood or meaning. So this is the end. So thank you very much.
Thank you, John. Are there any questions to him? His talk. I just have one clarification. Oh, can I have a question first? Maybe I missed the part, but how to relate self-image by learning from the random motion to the design movement, where the self comes from?
So that means
maybe you explain in the beginning of the introduction, but
introduction. Sorry.
Why you can say this is a self-image?
So why you can say so? Maybe this word is meaning like vision. So because so self-image, but so this is my.
So this is the transformer and mapping from the sensor value to motion or to
motion.
To motion. Okay.
Motion, motion degree.
So it's like a body image. You mean like the robot learn a body image where the body is in relation to.
I think body image is embodiment, getting information from some like pressure or something and making image. So imagine where is my body. This is so translate for so self-image. I think self-image is a system of translate some input for body movement. Exchange like exchange body image, body movement. How I'm moving,
Yeah,
my
I
hand
see.
is theirs.
I think there's some confusion between body image and body schema. Sometimes the philosopher using, the two different notions. I'm maybe a bit confused between these two concepts.
So
But
this
yeah.
is a, and so I think I have to study more. Yeah, background.
Okay, thank you. Hiro, do you have a question?
Yes, I had a similar question, but another one. I might not understand correctly, but you said you prepared two kinds of motion. One is random and one is designed by human. And then is there any difference between the body images of the body images? Is there any differences between the body image created by the random motion and created by the human design motion?
So we try to make other data, like I deleted. So we try we recorded so many data, like a simple move or like hands up down, or so left hand or right hand and moving west, and so many data. But so random move to so human design move is so best, and so best score, the best score.
No. The random motion is necessary to create the body images.
So what, I don't know why, but we try to make body image so using so human design data, random data, and very simple movement, and score highest score is a and so random move learning model is a highest score.
Okay, I understand. I thought it might be related to the motion bubbling by the babies. So the babies generated the random motion at the beginning, and then those motions are going to be self-organized. But I don't know if it's related to the body images. But yeah, okay, thank you. I understand.
Yeah, and maybe we need more, but making more pattern or something.
Tatsuo Unemi.
Yeah, thank you. Thank you very much for the very exciting talk. Because I used to be a very active life researcher, but now almost the artist. So that's very good artwork. I think, I believe, because the one with this, yeah, just a comment. So just one of the very important measurements of the value of the artwork is that's how strongly it can confuse the audience. So that's a very good. So everybody, scientists are confusing, and the audience of the ordinary audience is also. I think they believe the different way of the interpretation of agency of the robots. So yeah, okay. So just a comment. That's good work.
Thank you. Thank you.
Well, can I add one thing?
Sure.
So comparing with other speakers, what Johnson wanted to say was that, so for example, like Hiro's work is to make a model of the environment and try to understand how one scene is connected to the other, right? So the prediction of the external world. But also, as Hiro mentioned, that ontogenetically, the human can generate his own body schema, right? Then after that, he has to use his body schema to do something that he intended to do, right? That's what we call body image. So the bodies, based on body schema, that we can make a body images, right? So that the random motion is about the body schema, and based on that, whether we can do imitation or not is a problem, right? But we cannot use external signals to generate a body schema or a body image, right? Because everything has to be generated from the signal that we can get from the inside. Means the proprioceptive signal is the only the thing that we can use. So depending on this Android has 40 sensors, and using 40 sensors to guess what sort of shape or the pose that the Android is now having should be guessed from those sensors only, right? That's what the problem is. So we think it's very, very normal and easy problem, but for the living systems or living machine that we can generate, I think it is very difficult to have a body schema and images, right? Only from the internal signals. That's what he tried to do. And transformer is one of the way without using any, different connections, but because of this attention dynamics, which is embedded in a transformer, that which part of the body that which part of the proprioceptive sensor that we have to pay attention to do some sort of action pattern. That's what the basic project that is underneath of this his talk.
Thank you. It actually sounds a bit like the active inference idea to make an action. So
That is true. Yes.
yeah, it's really interesting. Okay, so I think we finished the first part of the session. And how